1. What are Docker networks? Docker networks allow communication between containers while providing isolation from the host system and other networks. They enable multiple containers to interact securely and efficiently as part of an application stack. By default, Docker provides different types of networking options that define how containers communicate with each other, the host machine, and external networks. 2. Why are Docker networks important? Docker networks are crucial for the following reasons. 1. Container communication. Containers often need to interact with each other, e.g., a backend API container communicating with a database container. Without networking, containers would be isolated and unable to exchange data. 2. Isolation and security. Docker networks isolate containers from one another, preventing unauthorized access. Containers within a network can communicate freely, while others remain restricted. 3. Service discovery and DNS resolution. Containers can refer to each other by name instead of IP addresses. Docker automatically assigns a host name to each container in a user-defined network. 4. Scalability and microservices architecture. Microservices need to communicate efficiently in a distributed system. Docker networking simplifies this process by managing service discovery dynamically. 5. External communication and load balancing. Containers can expose ports to be accessed from the host or the internet. This allows applications inside containers to serve requests from external users. 3. Types of Docker networks. Docker provides 5 different networking modes, each designed for specific use cases. 1. Bridge network, default. Default network. Used for container-to-container communication on the same host. Containers get separate IPs and can talk via host names. Suitable for multi-container applications, e.g., Web plus DB. 2. Host network. No isolation. The container directly shares the host's network. No separate IP. It uses the host's IP and ports. Best for low-latency applications, e.g., Jinx databases. 3. Overlay network. Multi-host communication. Enables container communication across multiple hosts. Used in Docker Swarm for managing distributed applications. Ideal for microservices architecture across multiple servers. 4. MAC-VLAN network. Acts like a real device. Assigns a physical MAC address to containers. Appears as an actual network device on the LAN. Used when containers must communicate directly with external networks. 5. None network. No connectivity. Disables networking completely. No access to other containers or the internet. Used for security and isolated environments. 4. Docker network types explained in detail. 1. Bridge network, default. What is it? The default network in Docker allows container-to-container communication on the same host. Each container gets an IP address and can communicate using host names. Use case. Used when multiple containers need to communicate within the same machine, e.g., a web app container talking to a database container. Small blue diamond example. Step 1. Create a custom bridge network. Docker network create MyBridge network. Step 2. Start 2 containers in the same network. Docker run d, name app, network MyBridge network Jinx. Docker run d, name db, network MyBridge network MySQL. Step 3. Verify connection between containers. Docker exec it app ping db. If successful, it means the app container can communicate with a DB container. 2. Host network. What is it? The container directly shares the host machine's network. No network isolation. The container uses the host's IP and ports. Use case. When performance is critical, e.g., low-latency applications. Running web servers that need full host network access. Example. Run a container using the host network. Docker run d. Name my app. Network host Jinx. The container now runs directly on the host's network. Check running containers. Docker PS. The Jinx web server is now accessible on the host's IP address. Pros and cons. Pros. The no network overhead, better performance. Useful for applications needing direct host access. Cons. No isolation between the container and host. A risk of port conflicts. 3. Overlay network for multi-host communication. What is it? Allows containers to communicate across multiple Docker hosts. Used in Docker Swarm for container orchestration. Use case. Running a cluster of services across multiple physical or cloud servers. Example. Create an overlay network. Docker network create. Driver overlay my overlay network. This network can now be used across multiple Docker hosts. Run a service in swarm mode. Docker service create. Name web. Network my overlay network Jinx. The web service is now available across all nodes in the swarm. Pros and cons. Pros. Enables multi-host container communication. Ideal for highly available applications. Cons. Requires Docker Swarm mode. Complex setup compared to bridge networks. 4. Macklin network for direct network access. What is it? Assigns a real MAC address to the container. The container appears as a physical device on the network. Use case. When a container must act like a real device, e.g., running network simulations. When integrating Docker containers with existing physical networks. Example. Create a Macklin network. Docker network create. d-macklin / Subnet equals 192.168.1.0/24 / Gateway equals 192.168.1.1 / O parent equals eth0 my Macklin. Run a container on the Macklin network. Docker run d. Name net container. Network my Macklin busybox sleep 1000. Pros and cons. Pros. Provides direct network access with a separate IP and MAC. Containers can appear as real network devices. Cons. Not supported on all network environments. More complex setup. 5. None network, no connectivity. What is it? Completely disables networking for a container. The container cannot communicate with other containers or the host. Use case. Running sandboxed applications. Ensuring complete isolation from external networks. Example. Run a container without networking. Docker run d. Name isolated container. Network none Alpine Sleep 3600. Pros and cons. Pros. Provides maximum security, no external access. Cons. No communication with other containers. 5. How to list and inspect Docker networks. List all networks. Docker network ls. Inspect a specific network. Docker network inspect MyBridge network. Remove a network. Docker network rm MyBridge network. 6. Conclusion. Docker networks play a critical role in containerized applications. Depending on your needs, you can choose 1. Bridge, default, for container-to-container communication on the same host. 2. Host, directly uses the host's network, good for performance. 3. Overlay for multi-host communication, Docker Swarm. 4. Macklin, when containers need real network identities. 5. None, for completely isolated containers. Each network type serves a specific purpose, making Docker networking a powerful tool for building scalable, distributed applications. For more such videos, please subscribe, like, and share this video. Thank you.